Hi everyone, my name is Janke, and today I'm going to be chatting to you about unraveling the forage quality of pasture mixtures under grazing. So the data I'm going to be presenting here actually formed part of a bigger farmlet study where we evaluated a Kikuyu ryegrass pasture and also then a tall fescue plantain red clover mixture, a chicory lucerne ryegrass mixture, and also a monoculture of tall fescue and plantain. So you're welcome to follow that QR code. It will lead you to a presentation where we discuss the pasture yielding potential, the pasture composition, and also the milk yielding potential of these different systems. But for today, we're going to focus on forage quality, and we're actually also only going to focus on the top 3 pasture systems, which were all mixtures. So when I initially started looking at this forage quality data for the different systems, I very quickly realized that in terms of forage quality, pasture systems are actually quite complex, and they're a bit like a puzzle where you need to put all of the different pieces together. So the forage quality, the milk yield, changes in botanical composition, put them all together, realize how they fit together, and then at the end of the day, hopefully you get a bigger picture that makes sense rather than just a whole lot of jumbled up pieces. So how are we going to approach that for this presentation? Well, what I basically did was I went and I took all of the forage quality parameters listed there, and I drew up correlations between them and the monthly milk yield of each system. Only the parameters that were highly correlated were then taken, and I again drew correlations between them and the changes in the pasture composition of the different systems. So correlated each of them with different components. So let's talk a little bit about correlation. So there are basically 2 types of correlations. The first type of correlation is a positive correlation, and you can view it almost like a tractor and a trailer. When one goes up, the other one follows and also goes up. And also when the one goes down, the other one goes down with it. The second kind of correlation is a negative correlation, and you can think of that more in lines of a seesaw. So when the one parameter goes up, the other one goes down. But those aren't the only considerations when looking at correlations. You really have to consider the strength of the correlation. So there are different degrees of correlation. So when your correlation coefficient is between 0.9 and 1, we classify that as a very highly correlated correlation. Between 0.7 and 0.9, we say it is still strong. 0.5 to 0.7, we say it is moderately high. By 0.5 or 0.3 to 0.5, we say it is a moderately low correlation, whilst by the point that we get where it is below 0.3, we say that it is a very weak correlation, or there's really no correlation or linear correlation between the 2 parameters. So for the purposes of this presentation, to keep it short and concise and relevant, we are actually only going to focus on correlations that were above 0.7, so highly correlated. So let's jump right in. So the first set of correlations we are going to look at here is the correlation between milk yield and the different forage quality parameters of Kikuyu ryegrass. And what we found was that milk yield was highly correlated with non-fiber carbohydrate content, or NFC, negatively correlated with neutral detergent fiber content, or NDF, and positively correlated with dry matter intake. So just to show you that I'm not sucking my thumb on this, so let's look how the milk yield would change as the NFC content changes. So on this graph in blue, we have the daily milk yield of the cows during the study period, and in black, we have the NFC content of the pasture. And as you can see, as the NFC content goes up, the milk yield tends to go up, and when it drops, the milk yield tends to drop as well. So what are the drivers of NFC content in a Kikuyu ryegrass system? We again looked at correlations, and we found that the NFC content was negatively correlated with Kikuyu, basically indicating that when your Kikuyu content in the pasture increases, your NFC content will increase and your milk yield will drop. In a similar vein, we found that NFC was positively correlated with ryegrass content in the Kikuyu ryegrass pasture. So basically, as your NFC or as your ryegrass component increases in the pasture, the NFC will increase, and in turn your milk yield will increase. So this is a very seasonal pattern and very characteristic of the system. Now, let's talk a little bit about dry matter intake in cows. So when we try to determine the dry matter intake requirement of a cow, There are numerous factors that you can take into account when calculating it. So, for example, milk yield, pregnancy status, days in milk, body weight, walking distance, environmental conditions, and there's a whole list of more parameters you can look at. And equally, there are a large number of models used to predict dry matter intake requirements of cows. But for the sake of this presentation, I really want to keep it quite simple. So we're simply going to say that the dry matter intake requirement for a dairy cow is 4% of her body weight. So for a 450 kilogram cow, that would equate to about 18 kilograms per day. Now, the importance of this is that when we look at the potential dry matter intake calculated for the pastures in this presentation, you would use that equation. So it's strongly driven by her weight, which is 450, but also by the NDF content of the pasture. The importance of this is that any shortfall we have between that 18 kilograms we need for the cow and the potential dry matter intake of the pasture, which is a characteristic of the pasture itself, will have to meet in some other way. And in our systems, that's mostly through concentrate feeding. So we really want to keep the potential dry matter intake as high as possible and the need for concentrates as low as possible. So let's move on to the dry matter intake potential of the Kikuyu ryegrass system relative to the milk yield again in blue. And that was as already seen, positive correlation. So the more pasture we can get into our cows, the higher milk yielding potential it would have on a Kikuyu ryegrass system. But it also works the other way. So when dry matter intake becomes a constraint, it means our milk yield from the system is dropped. So what is constraining dry matter intake in this particular system? And the simple answer, again, comes down to the Kikuyu content. So when our Kikuyu content increases, we see that dry matter intake takes quite a knock, which means that a high Kikuyu content in your pastures is basically constraining dry matter intake in that cow and having a very negative impact on her milk yielding ability. Now, we all know this about Kikuyu, but the question is it only a Kikuyu thing? Could it be a seasonal thing as well? So are the cows just struggling to get enough feed into themselves during certain seasons because something else is negatively impacting the NDF content of the pasture? And the simple answer is, unfortunately, yes. Kikuyu is a major driver because once you plot the dry matter intake potential of our mixture of tall fescue, plantain, and red clover in yellow, next to that of the Kikuyu ryegrass system, we see that that dry matter intake potential off of the mixture is continuously higher up to a certain point, which is here in the summer and spring, leading through to autumn of the third year. And this was strongly associated with the increase in the Kikuyu content of that mixture. So it started invading that mixture. So yes, unfortunately, Kikuyu does limit dry matter intake on a system, whether you want it there or not. Which brings us to the next set of correlation coefficients I want to discuss, and that's for the correlation between the milk yield of the tall fescue, plantain, red clover mixture and the forage quality parameters. What is noticeable here is that we now only have one parameter, which is metabolizable energy content, which was highly correlated with milk yield in the system. So that's the main one we're going to discuss. So again, graphing the milk yield in blue and the metabolizable energy content in black, we do see that it is most likely correlated, where the milk yield obviously dropped as the ME content dropped in the pastures. Now, we all know that metabolizable energy is an important factor determining milk yield from pastures. But what I really want to focus on is when does the ME become so constrained that it's actually limiting milk yield in a tall fescue, plantain, red clover mixture. And what we found was that the ME content in this mixture was limiting predominantly during the summer and autumn of both year 2 and year 3. And what was interesting is that the ME content of the pasture was highly positively correlated with the plantain content and highly negatively correlated with the weedy grass content, which is in yellow, and the plantain is in blue and green on this particular graph. So what we kind of took away from these graphs and the correlations was that once the weedy grasses contributed more than 15% to the sward composition in this kind of mixture, so it was starting to be invaded, our ME would drop below 10.5, which is the requirement for our dairy cow, but also that it was important to maintain the plantain component at more than 60% if we wanted to maintain a good ME profile for our pasture mixture. So in this system, we would really be focusing on maintaining our plantain component and keeping those weedy grasses out. Now moving on to the last mixture. So once I started looking at this data, I became a bit deflated because, as you can see, there were absolutely no forage quality parameters that were highly correlated with milk yield in this study. But I forged ahead and thought, well, maybe there was one of the pasture components that was at least driving even our low, moderately correlated forage quality parameters when it came to milk yield. But unfortunately, even if we look at it in this way, there was no primary component that was really driving any of our forage quality components. So at this point in time, it's very difficult for us to discern what drives milk yield on a chicory, lucerne, ryegrass pasture, and also what drives changes in those forage quality parameters. So what am I trying to say through all of this data and these correlations? Well, at least the good news is that we have definitely confirmed that as kikuyu increases in any pasture type, the NDF increases to the point where it will limit pasture intake and inevitably lower your milk production. So kikuyu is really not conducive to producing a lot of milk. What was good news is that we also did find that if you have plantain in a mixture at a high enough level, it increases the ME content. It also supports high intakes, and that really stimulates high milk production. So important to maintain that forage herb component if it's plantain in your pastures. What was also quite apparent after looking at all of this data was that the kikuyu ryegrass system is like a really simple puzzle. It's simple to understand. Forage quality is strongly driven by the seasonal seesaw between kikuyu and ryegrass. And kikuyu basically is a constraint to our milk production, and the ryegrass can stimulate it. So the longer you can keep the ryegrass in and the kikuyu out, the better your odds of maintaining milk production on that system. The tall fescue plantain red clover system was a bit more complex, a bit more factors to consider. But the primary takeaway here was that you do need to maintain that plantain component to maintain a high forage quality in terms of metabolizable energy and dry matter intake and keep those weedy grasses out. And then getting to our last system, which was that chicory, lucerne, ryegrass system. So at the end of the day, I realized I thought I was trying to build a puzzle, but what I had been handed was actually just a whole box of Legos. Then told to build something, but not told what it was, and I wasn't given any instructions because there were no discernible patterns that I could kind of figure out of that system. The good news is that now we know that we need to further our understanding of chicory, lucerne, ryegrass pastures. So what could we look at? Could we consider that the correlations between forage quality, milk yield, and pasture compositions aren't strictly linear? Are they a bit more complex? So we will need to model that using more complex strategies. The second thing is, I think that the changes in pasture composition and forage quality in these systems are so rapid and unpredictable and variable on a spatial and time scale that we probably need to quantify them better. So the first thing would be to get a better way to quantify changes in botanical composition in these very complex pasture mixtures. And then also consider that maybe the NIR we use to analyze these samples is not yet capable of estimating it accurately, the forage quality. So they'll have to develop a bit more robust models for pastures that contain chicory, lucerne, and ryegrass. Thank you, everyone, for listening, and please feel welcome to contact us if you have any questions.
In this presentation, I will be sharing some preliminary results from the evaluation of grazing type red clovers at Outeniqua Research Farm. The reasons for evaluating red clover cultivars, and particularly ones that are termed grazing types, is to search for more persistent cultivars that can match with the persistence of other components in the mixtures that we use in the dairy pastures, and to fit with commonly used mixtures as an alternative legume component, where the other legume that is commonly used is lucerne. So the red clover may be an alternative to this. Red clover has different types, and these are categorized into annual types and grazing types. So the annual type has been extensively used in South Africa up to now, and generally these do not persist for more than about 18 months. The other types are considered grazing types, and the questions we have regarding the grazing types is there winter dormancy? Is there persistence under frequent defoliation? What is the yield potential? And does the height match that of other tall growing components, like, for instance, chicory? This graph represents the total yield of the first 13 months, which includes the establishment period. This trial was planted on the 14th of March 2023. Oregon Red is used as the control variety, and one variety, Morrow, was similar to Oregon Red over the first 13 months, while a whole host of varieties, which all have a designation of an A in the designations above the bars, were similar to the control. And then there were some varieties, the last 5 here, which were lower yielding than the control. This graph represents the total yield of the second trial, which was planted later, a month later, on the 12th of April 2023. The later plantings seem to favor the annual type, which in this case is Oregon Red, and possibly Dynamite is also a more annual type, and all the grazing types were lower yielding than the control up to this point. Overall, this later planting, even though it had one harvest less than the first planted trial, the overall yield was higher at 18 tons dry matter per hectare, while the first trial over 9 harvests came to 16 tons for the highest yielding. So the later planting seemed to favor the annual type, and it had a higher yield overall. This graph represents the winter yield of the first trial, and it illustrates very clearly that there are large differences in winter growth activity, and the annual type was significantly the highest yielding in winter, being Oregon Red, and then varieties like Relish, Morrow, Amigaine, and Barduro were statistically similar to Oregon Red, and all the rest were very dormant and significantly lower yielding than the control. Then we look at spring. This is in the first trial, and there most of the varieties yielded very similar to the control, and it was only on the far right, the last 6 varieties that yielded lower than the control. For the second trial, the spring yield again favored the annual types, and the grazing types were significantly lower yielding, although they still achieved a yield of 8 tons dry matter per hectare, while the lower yielding ones were at around 6 tons. This slide shows the summer yield for the first trial, And in that top group, which starts with Calico right through to Barduro, all designated with the A, basically most of them are ones that were winter dormant, but except for Moro and Barduro, which are winter active, but are also in this top group for summer. The rest are winter dormant varieties that have very high summer production. For the later planted trial, the second trial, the summer yield was higher again than the first trial. This trial yielded almost 8 tons for the best variety, while in the first trial it was just under 6 tons. And again, there were varieties of the grazing types that yielded better than the control, while some of the grazing types also yielded lower than the control, as opposed to the first trial where most of the grazing types yielded higher than the control. If we look at the spring and summer yield, this is for the second trial, both in one graph. The blue bars represent the spring yield and the orange bars the summer yield. We can clearly see that for most of the varieties, spring is the superior season, while there were 3 varieties, Geert, Hajan and Griegale, where the summer was superior to the spring. So that was an interesting characteristic which set them apart from all the other varieties. If we look at the height, this is the mean height in the first trial of all the varieties in spring, and Oregon Red and Barduro were the tallest at about 40 centimeters, right down to the shortest variety on the right-hand side here, which reached a maximum of 25 centimeters. So quite a range of heights that these different varieties are able to attain, and this may be an important characteristic if one considers mixtures, and especially if mixtures contain tall growing components like chicory, for instance. We also measured the green leaf area using the Canopeo app, and this graph represents the green leaf area after 10 days of regrowth. This was in January 2024, and there is quite a substantial difference and a very significant difference in green leaf area. So some of the varieties have a very high percentage of green leaf area very early on, which also means they have a good ground cover. And some varieties, like the ones on the far right and the control Oregon Red, which is the second to last, have a relatively poor leaf area early on in the regrowth period. Then we looked again at the leaf area in April 2024, this time 21 days after harvesting, so 21 days of regrowth. And as expected, a whole lot of the varieties have now reached a fairly high green leaf area, but there is still a significant difference, Oregon Red being on the far right, second to last, the control, and there are varieties that are significantly lower than some of the grazing types in terms of their green leaf area. To summarize the observations after the first year of the evaluations, and this is really only the first year, the years to come will give us more insight into the performance and persistence of these grazing types. So some of the grazing type cultivars are winter active, which is a positive, while most are winter dormant. The peak yield is in spring. Winter dormant cultivars have the best summer yield though, and the green leaf area and ground cover is best in the grazing types. Possibly a mixture of the two types would give a good yield distribution and a good ground cover, and the persistence will be evaluated going forward. Thank you.
Good morning. Today we will be discussing plantain and how it changes in terms of forage quality during regrowth. The grazing cycle of intensively used dairy pastures is important in the overall productivity and efficiency of the pasture system. The criterion mostly used to decide on the grazing cycle is physiological stage of the plant. This is done to optimize yield and persistence. Forage quality is also an important criterion, and for species like ryegrass, for instance, it is known that the forage quality and the free leaf stage are closely linked. In the case of plantain, the physiological stage is less important in terms of persistence and yield. In this study, a sequence of samples was taken following defoliation to determine the forage quality of plantain, Plantago lanceolata, as the regrowth phase progresses, and ascertain the optimal timing of grazing in terms of forage quality. Plantain plants of the cultivars Outeniqua, Tonic, and Captain from an established ward on the Outeniqua Research Farm were defoliated and sampled on a weekly basis for a period of 6 weeks during winter. No plant was sampled more than once. Approximately 400 grams of pasture was cut at 50 mm stubble height and weighed wet, dried at 70 degrees Celsius, and weighed dry. Samples were then milled with a hammer mill using a 1 mm sieve. Samples was analyzed using NIRS. Crude protein and water-soluble carbohydrate values followed the expected trends, where crude protein decreased over time and water-soluble carbohydrates initially decreased and then increased to a peak, followed by a decreasing trend thereafter. Crude protein stayed within a reasonable range from week 1 to 5, peaking at week 2 at 22.6%. Week 6 tended towards the low end, but was still reasonable at 16.9%. Weeks 5 and 6 were significantly lower than weeks 1 to 4, with weeks 4 and 5 at 20.7 and 18.3% respectively, but still in the acceptable range for dairy cow requirements. Water-soluble carbohydrates increased from week 3 at 10.6%, peaking at week 5 with 14.3%. There was no significant difference between weeks 4 and 5, with week 4 at 12.4%. Water-soluble carbohydrates decreased to 13.2% at week 6 and onward. The water-soluble carbohydrate to crude protein ratio follows the S-curve. The ratio peaked at week 5 at 0.8% and then levels off. Neutral detergent and acid detergent fiber content follow the quadratic function. The lowest neutral detergent fiber value, 30.8%, was at week 4, but all were highly favorable. Acid detergent fiber's lowest value, 22.4%, was at week 5, although not differing statistically from all other weeks, with the exception of week 1. Lignin decreased linearly from 18.7% to 15.7%. The data shows that the main quality parameters informing decision-making for defoliation interval to be water-soluble carbohydrates and crude protein, with the most favorable ratio, according to this dataset, at week 5, thus a 35-day rotation. Initial nitrogen fertilization was done 4 days after defoliation. An earlier application may have led to an earlier peak in the water-soluble carbohydrate to crude protein ratio. Fiber components were all decreasing up to week 5. But how flexible is the grazing window? From a crude protein and neutral detergent fiber perspective, this pasture can be grazed from a 21 to 35-day interval with no negative effects. However, when taking water-soluble carbohydrates into account, a 28 to 35-day cycle would be favorable. This trial should be repeated in spring or summer, with more extensive sampling. Thank you.
In this presentation, I will give a summary of the latest data for the evaluation trials of forage herbs, ryegrass, and cocksfoot. And for the cocksfoot, this will also include some forage quality data. The results for trials established in March 2022 at the Outeniqua Research Farm will be covered in this presentation. The perennial ryegrass, forage herbs, which is plantain and chicory, and cocksfoot. And more detailed trial results are available in the book. To start off, we look at the perennial ryegrass data. In this graph, we see the yield for the perennial ryegrass of year 1 compared with year 2. The blue bars represent year 1 and the reddish bars represent year 2. Importantly, the dark blue bars in year 1 is the highest yielding group, and for the second year, year 2, the highest yielding cultivars are also within that group, meaning that the best cultivars did well in year 1 and in year 2. The yield decrease from year 1 to year 2 was between 22 and 44%, depending on the cultivar. To put it all together, this graph shows the additive yield for the 2 years, and the dark green bars show the top group, which are all designated with an A in the stats analysis. In this slide, it shows the winter production for the perennial ryegrass. Again, year 1 versus year 2. So the first winter is shown by the dark blue bars, and the second winter by the reddish bars. And the top group for the first winter ranges from the cultivar Governor and Platform being first, right through to Maxon and Sequel at the other end of the top group. In the second year, only 3 of the cultivars in the top group are also in top again, which means the yield decrease in year 2 was quite substantial for most of the cultivars, and the percentage decrease ranged from 32% to, in the worst case, 58%. This graph represents the summer yield, with the blue bars the first summer and the orange bars the second summer. And even for the first summer, there's a substantial difference. So we can see that Platform performed well in the first summer at around 4.4 tons dry matter per hectare, with other cultivars in that top group being Legion, 150, Maxon, Governor, Achilles, and Rockstar, with Achilles and Rockstar being the Festiloliums. But the second summer was very variable, and some cultivars really did not perform very well in the second summer, as one would expect, but a bit unexpectedly, all the Festiloliums did not do well in the second summer. This graph represents the NDF percentage, which was taken in late spring, being November. And there is again a wide range of NDFs in that late spring period, ranging from about 45% right through with the highest NDF at almost 52%. And there was a strong relationship with rust and flowering, with these higher NDF varieties either having a high rust rating or having a high flowering incidence. And that to some extent explains the variation in NDF as we see in this graph. To summarize the perennial ryegrass data, the growth rates that were sufficient to support a Jersey dairy herd, which is stocked at 4 cows per hectare, and assuming they require 10 kg dry matter per cow per day from the grazing, the growth rates only of the highest yielding cultivars matched that requirement for winter and summer. Towards the end of summer, which would be February, and into autumn, the growth rates were too low to support such a dairy herd. The second year yield was insufficient, and hence oversowing would still be required on an annual basis. The plant population is very low in late summer, and it only recovers in late autumn as it gets cooler, and this is also reflected in the yield and the quality in late summer. And perennial ryegrass would best be used in a mixture with summer active species such as forage herbs and legumes. Now let's look at the forage herbs, which are plantain and chicory. This graph represents the yield of the first year from an autumn planting. And in the first year, the chicory cultivars outperformed the plantain cultivars. The plantain cultivars are designated with a P behind the name. And the first year yielded about 20 tons dry matter per hectare, which is a reasonably good yield from an autumn planting. In the second year, the order was reversed, and the plantain cultivars outperformed the chicory cultivars significantly, except for the chicory cultivar Commander, which was in the group similar to the highest yielding plantain. Comparing the yield of year 1 and year 2, generally there is a decrease in year 2. The average decrease for plantain was around 14%, and for chicory around 30% on average. And this mainly was a function of a decreased plant population. This graph represents the total yield of the 2 years. The trial ran for 2 years, and this is the total yield for those that combined 2-year period. And then all the cultivars were actually similar to the highest yielding, both chicory and plantain, except for the plantain cultivar Oracle, which was lower yielding than the top yielding cultivars. The main advantage of the forage herbs is the production in the spring, but also the first summer going into that second autumn. This would now be from an autumn planting. And here the blue bars represent the first summer, while the brown bars represent that autumn following the first summer. And we can clearly see the dark blue represents the highest yielding varieties in the first summer, and those are the 3 plantain varieties. The chicories are all in the light blue, which were significantly lower yielding. And then in the following autumn, following this on the summer, the plantain varieties Captain and Agritonic were the highest yielding and out-yielded the plantain cultivar Oracle, as well as all the chicory cultivars. So generally one can say that the plantain cultivars Captain and Agritonic were superior in both seasons. The plant population after the 2-year period is represented in this graph as a percentage of the population at establishment. And one can clearly see that the plantain varieties on the left in the dark green still had a significantly higher plant population left after 2 years of between 37 and 45% depending on the cultivar, while the chicory varieties all had a very low plant population that was insufficient to sustain production going forward. In summary, for the plantain and the chicory, an autumn establishment gives a satisfactory yield compared to a spring planted establishment. The previous evaluation trials were all spring planted, as opposed to this one, which was autumn planted. So autumn planting is a possibility. The production in the first winter is less from an autumn planting than from a spring planting. The growth after establishment in the colder months is slow at only 31 kgs dry matter per hectare per day, while if the plants are established in the previous spring and are already well established, the yield is more favorable in the next winter. Spring, summer, and autumn yields are all good. The spring growth rates were on average of the highest producing cultivars were 75 kgs dry matter per hectare per day. In summer, it reached 100, and that was mainly plantain only. And in autumn, for the plantain, it was at 50. The plantain is more perennial than the chicory, and the chicory and plantain can be autumn planted in a mixed pasture with grasses and legumes. Lastly, we look at the Coxford data. This graph represents the yield of the first year. There were 9 of the 14 cultivars that were in the highest yielding group, and the first year produced just under 20 tons dry matter per hectare for the best yielding cultivars. In the second year, 7 out of the 14 were still in the highest yielding group, with the highest yield at just under 15 tons dry matter per hectare, and that incidentally was from the same variety at Remo as in the first year. The differences in the second year were partly also due to leaf diseases having an effect, resulting in some of the varieties having a lower production. This graph represents the yield decrease in year 2, where the blue bars are year 1 and the reddish bars are year 2. So generally it was around 30% yield decrease, although some had as much as 37% decrease, others 33 and 34%, but generally it was around 25 to 28% decrease in year 2. But one has to add that in year 2 had 1 less harvest and thus also less nitrogen than year 1, as the nitrogen is always given after the harvest. It is important to look at the winter yield, because we would want to select varieties that are winter active, and this graph clearly shows the winter active versus the winter dormant varieties, with Bardaris being the most winter active, followed by Archibaldi, Savvy, Captor, and Oberon, while the rest showed various degrees of dormancy. This graph represents the spring and summer yield of the first year. The spring is represented by the blue bars, which is the season that has the peak yield for Coxford, and there was a good spring yield of just over 9 tons dry matter per hectare in that 3-month period for the best producing varieties, and most of the varieties were similar to the highest yielding. It was only the last 3 on the right hand side that were lower yielding in the first year. The summer of the first year, though, was lower yielding than one would have expected, but that pattern was also repeated in the second summer. Importantly, of the varieties that were in the highest yielding group for spring, there were also 2 in that group in the summer, being Innervale and Olathe. This graph represents the spring and summer of the second year. Importantly, the second spring is the yield is approximately 40% lower than the first spring. There were, again, 6 varieties in the highest producing group for spring, which are the blue bars, and the dark blue bars being the higher group. And the summer yield was relatively variable, with some of the lower spring yielding varieties doing well in summer, or relatively well in summer, being in the higher yielding group. To now look at some of the forage quality parameters. This is the NDF percentage, with the highest NDF being about 51%, down to the lowest 39%. The varieties with the asterisk, with the star, represent the highest yielding varieties in that particular season, and those mainly are in the highest NDF group, which is on the left-hand side. So it seems that the higher yielding cultivars also have a higher NDF. This will need to be confirmed with values for the other seasons going forward. Similarly, the dry matter digestibility, again, the varieties with the asterisks were the high yielding varieties. They all are towards the right-hand side of the graph mainly, which has the lower digestibility, and the ones on the left-hand side with a higher digestibility were generally the lower yielding varieties. This graph represents the potential dry matter intake based on a 450 kg cow. And again, there's quite a significant difference between the varieties. And as we saw in the previous graph, the highest yielding varieties appear more on the middle to right-hand side of the graph, meaning that they had, due to their higher NDF, had a lower potential dry matter intake value than did the lower NDF cultivars, which are on the left-hand side of the graph. If we look at this in combination on the the bottom axis represents digestibility, with increasing digestibility from left to right. And on the vertical axis is the yield. So if we plot the varieties, their yield against their digestibility, they group into 2 or 3 groups, really. On the right-hand side here, the group of varieties that have a very high digestibility, or the highest digestibility we see are the lower yielding varieties. This graph shows it very nicely. And on the left here are the very high yielding varieties, but which have the low digestibility. And what stands out is the 2 varieties, Bardaris and Savvy, which have a high yield and still a reasonable digestibility. Similarly, if we look at the second winter, on the right here we have the high digestibility varieties, but they have a lower yield. And on the left-hand side, we have the high yield at the top, the high yielding varieties, but the lower digestibility. The one that stands out in the second winter is Orris, which has the highest yield and a high digestibility. To conclude the Coxfit data, there was a good total annual yield, and this was especially the case in the first year, but the second year also had what one could consider a reasonable yield. Spring is the peak season for Coxfit, and this may have potential for silage making. Summer was not as good as expected, and one would thus have to combine it with a forage herb and a legume to up the yield in summer. And some cultivars are winter dormant. The good yield seems to be associated with the lower forage quality, and this will have to be confirmed with samples from spring and summer, which still need to be analyzed. Some cultivars had reduced sward density in the second year. And finally, the best cultivars could be used in mixtures, but possibly rather on the outer fields rather than the main dairy platform. Thank you.
Good day, my name is Miller Cronje, and today it's my privilege to present my MSc study done under the supervision of Prof. Robin Meeske and Dr. Lopke Steyn at the Outeniqua Research Farm. I was looking forward to present my study in person, but now at least technology ensures that nothing will be missed, as my speech can be listened to over and over and over again. The increasing trend towards intensification forces concentrates to form a larger part of the dairy cow's diet. This results in a less resilient system, more dependent on a milk-to-feed price ratio. Milk production response to increased level of concentrate follows the law of diminishing return, meaning that once a certain level of concentrate is surpassed, each unit increase in concentrate will result in less than 1 unit increase in milk production and thus reducing the profit margin. One viable option to increase dry matter intake from pasture is to partially replace concentrate with a high-quality, fast-degradable pasture. The high-quality, fast-degradable pasture used in this study is the forage herb plantain. Plantain is mainly used in diverse pastures to increase production in summer months when ryegrass production and quality is poor. In this study, the low NDF and high moisture content of plantain allows for high intake and fast passage rate. According to literature and ryegrass rate of digestion, there should be space available in a rumen in the early morning hours. This is especially true where cows are subjected to long nighttime grazing periods. So the aim of my study, to determine if allocating additional plantain pasture into the ryegrass dominant pasture-based production system will increase pasture dry matter intake, increase milk production, allow feeding concentrate at a lower level without reducing milk production. Here is something to ruminate on. Are my cows' pasture requirements met? How can I increase my dry matter intake from pasture and be more profitable? A 2-week trial period allowed blocking of cows according to 4% fat-corrected milk, days in milk, lactation number and live weight. The 5-week trial period that followed was a factorial design of two pasture treatments, cows allocated ryegrass only and cows allocated ryegrass with additional plantain pasture and 2 levels of concentrate, 4 or 6 kilograms per cow per day. The study consisted of 60 cows with 15 cows per treatment. The treatments were as follows: ryegrass plantain 6. Cows grazed ryegrass day and night and were moved to plantain pasture before morning milking. These cows were supplemented with 6 kilograms of concentrate per cow per day. Ryegrass 6. Cows grazed ryegrass day and night and were supplemented with 6 kilograms of concentrate per cow per day. Ryegrass plantain 4. Cows grazed ryegrass day and night and were moved to plantain pasture before morning milking. These cows were supplemented with 4 kilograms of concentrate per cow per day. And then lastly, ryegrass 4. Cows grazed ryegrass day and night and were supplemented with 6 kilograms of concentrate per cow per day. So the idea was to see if milk production between ryegrass 6 and ryegrass plantain 4 can be maintained. Then we have successfully replaced 2 kilograms of concentrate with this high quality pasture, which is plantain in this case. Ryegrass pasture was allocated at 14 kilograms dry matter per cow per day to cows from all treatments. Cows grazed as two groups of 30 cows on different ryegrass pasture blocks in the same paddock, indicated by red and green in this picture. For the second grazing, these blocks were switched to ensure similar ryegrass pasture quality for both treatment groups. The cows allocated additional plantain pasture were moved 1 hour before the morning milking, when pasture was allocated at 2 kilograms dry matter per cow per day. Pasture samples of both ryegrass and plantain pasture were collected twice a week by placing a metal ring at 3 random locations and cut 5 mm from the ground. Concentrate samples were collected once a week by means of a grab sample from various feeders. Body condition score was done before and after the trial by the same technician. Cows were weighed at 2 consecutive days before and after the trial. This weighing occurred after the afternoon milking. Cows from all treatments were mixed before walking to the dairy for milking at 7 and 2:30. Individual milk production of each milking were recorded with Affimilk system. Composite milk samples based on the milk yield ratio was taken once a week, and as you can see, all cows were fitted with Affi-collars to monitor continuous rumination and eating time. Pasture samples were dried, milled, and underwent proximate analysis. Analysis for fat, protein, lactose, milk urea nitrogen, and somatic cell score were done on all composite milk samples. It is clear that ryegrass of similar quality was offered to cows allocated in ryegrass only and cows allocated ryegrass and additional plantain pasture. Note the plantain pasture was in full bloom, which caused the NDF content to be higher than expected owing to the reproductive stems, but still lower than the NDF content of ryegrass pasture. As expected, the mineral content of plantain is higher than ryegrass, especially note the higher calcium content of plantain. Plantain has a lower potassium content than ryegrass, which can be beneficial for cows during the transition period. Pasture was allocated using the average pre-grazing rising plate meter heights. Post-grazing heights of 11 and 12 indicate that pasture allocation was sufficient and that excessive pasture wastage did not occur. Precise pasture management was important throughout this trial to ensure that the amount of ryegrass pasture allocated to cows receiving ryegrass only and cows receiving ryegrass with additional plantain pasture was equal. So we have already established that ryegrass pasture of equal quality and quantity was offered to both groups of cows. So any difference in milk production based on the concentrate level is due to the plantain pasture alone. Similar kilogram dry matter intake from ryegrass pasture of 9.2 and 9.5 were estimated for cows grazing ryegrass only and cows grazing ryegrass with additional plantain pasture. This indicates that no substitution of ryegrass for plantain pasture occurred, meaning that any difference in milk production between cows allocated ryegrass only and cows allocated ryegrass with additional plantain pasture was owing to the plantain pasture alone. Significant difference in milk production between cows receiving ryegrass only and cows receiving ryegrass with additional plantain pasture. This difference was more pronounced at a lower concentrate level. Similar milk production between ryegrass 6 and ryegrass plantain 4 indicate that it is plausible to replace 2 kilograms of concentrate with a high quality, fast degradable pasture. No difference in milk fat and protein were observed. Slightly lower MUN content was observed when additional plantain pasture was allocated to cows, but still within acceptable range. No difference in somatic cell score was observed between different treatments and well below acceptable value for milk safe for human consumption. It is difficult to make any conclusion on body weight change in a relative short trial period of 5 weeks. All cows gained weight throughout this trial period. This increase was more pronounced when additional plantain pasture was allocated to cows. No significant difference was observed in rumination time and eating time. However, an increase in eating time of 21 and 13.4 minutes in 24 hours was observed when additional plantain pasture was allocated to cows receiving 4 and 6 kilograms of concentrate respectively, again highlighting the larger contribution of plantain pasture at a lower concentrate level. This graph shows the percentage of cows eating on an hourly basis. Notice the increase in the percentage of cows eating when cows are moved to plantain pasture at 6 o'clock in the morning. Also notice that the percentage of cows eating the rest of the day is similar, indicating that no substitute effect between plantain and ryegrass pasture occurred. Now we get to the important part, the economical evaluation. As we all know, we feed concentrate to buy in hectares, and thus increase the carrying capacity of our farm. This economical evaluation was done simulating a 100 hectare milk platform for each treatment. The number of cows per 100 hectares milk platform was calculated using pasture intake affected by the substitute rate between pasture and the amount of concentrate fed. The area of plantain pasture needed for morning grazing was also taken into account. Profit per cow per day can be increased by R4.37 and R10.64 when additional plantain pasture is allocated to cows receiving 4 and 6 kilograms of concentrate per cow per day respectively. While profit per cow was increased by a substantial amount when plantain pasture is allocated at a lower concentrate amount, we must not forget the role concentrate plays to increase carrying capacity and thus overall farm profit. To conclude, allocating additional plantain pasture increased pasture dry matter intake, which resulted in an increase in milk production. This benefit was more pronounced at a lower concentrate level. Similar milk production between cows grazing ryegrass only and receiving 6 kilograms of concentrate per cow per day compared to cows grazing ryegrass and receiving 4 kilograms of concentrate per cow per day with 1 hour grazing on additional plantain pasture in the morning milking indicate that it is plausible to replace 2 kilograms of concentrate with plantain pasture without causing a reduction in milk production, which resulted in a substantial increase in profit per cow.
Hello everyone, my name is Cherise Basson and I am a MSc Agric Animal Science candidate. Today I will be discussing the impact of Aspergillus oryzae fermentation product supplementation in pasture-based dairy systems. Before we dive into the details, I want to thank you all for taking the time to join me. Feel free to pause the video at any time if you need to take notes or review any part of the presentation. Let's get started. It is well understood that input costs in dairy production systems continue to rise, adversely affecting profitability. In pasture-based systems, energy is the first limiting factor, necessitating the supplementation of cows with concentrate. However, pasture remains the most economical feed source. Thus, enhancing pasture utilization is crucial for improving profitability. Fungal products have the potential to increase fiber degradation and dry matter intake, presenting a promising solution to improve efficiency in pasture-based dairy systems. Let's think of Aspergillus oryzae fermentation product as a hammer mill. The cow consumes the concentrate containing Aspergillus oryzae fermentation product in the milking parlor. It then moves to pasture for grazing. Aspergillus oryzae fermentation product provides the rumen fungi with essential metabolites promoting fungal branching. These fungi act like a hammer mill by breaking down cellulose, hemicellulose, and lignin-hemicellulose bonds. This process increases the surface area for bacterial attachment, ultimately leading to increased fiber degradation. This slide summarizes the mode of action of Aspergillus oryzae fermentation product. I have briefly covered it in the previous slide, but I would like to highlight that Aspergillus RSA does not only increase fiber degradation by increased fungal branching, it also increases lactate utilization, stabilizing rumen pH and creating a more favorable environment for the cellulitic bacteria that are responsible for fiber degradation. From previous research, it is evident that Aspergillus RSA fermentation product has the potential to increase milk yield, increase milk fat content, stabilize rumen pH, increase fiber degradation, and increase dry matter intake. But these studies were done on cows in TMR systems, and TMR and pasture-based systems are not the same. Therefore, the aim of this study was to determine the effect of Aspergillus RSA fermentation product on the rumen environment, fiber degradability, dry matter intake, milk production, and milk composition in Jersey cows grazing ryegrass dominant pastures in spring. Now, let's move on to the methodology. The treatments consisted of a control treatment and the Aspergillus RSA fermentation product treatment. Each received the standard dairy concentrate, but the Aspergillus RSA treatment had Aspergillus RSA fermentation product, also known as Ammoferm, mixed into the concentrate. This is the ingredient composition of the concentrate on an as-mixed base. The main energy source is maize and the main protein source is soya oil cake. Aspergillus RSA fermentation product was mixed in at 0.5 kilograms per ton. This is the calculated chemical composition of the concentrates. The concentrates were formulated for 16% crude protein and 12 megajoules per kilogram metabolizable energy. For the production study, 34 Jersey cows, 17 per treatment group, were selected from a group of 60 cows. These cows were blocked according to milk yield and composition, days in milk, and lactation number, and were then randomly allocated to the two treatments. The cows grazed as one group on ryegrass dominant pasture under sprinkler irrigation, with fresh pasture allocated after each milking. Pasture was fertilized with 28N after each grazing. The concentrates were fed at a rate of 3 kilograms per cow twice daily in the milking parlor. For the rumen study, we used a crossover design featuring 2 treatments and 2 periods. The treatments were the same as those used in the production study. We used 6 rumen cannulated cows with 3 cows assigned to each treatment. Following the first week of rumen observation, the cows were switched to the alternate treatment and allowed a 3-week adaptation period before the next week of rumen observation. The samples and data collected for the production study were as follows: body weight and body condition score on 2 consecutive days at the start and at the end of the trial, daily milk production, weekly milk samples that were analyzed for milk fat, protein, lactose, milk urea nitrogen, and somatic cell count, dry matter intake using titanium dioxide, and weekly pasture and concentrate samples. We also collected rumen fluid samples that were analyzed for rumen volatile fatty acid and rumen ammonia nitrogen concentrations. We measured rumen pH with the indwelling TrueTrack pH data logger, and we performed an Ensacco Dacron bag study that looked at fiber degradation. The nutrient composition of the concentrate and pasture analyzed on a dry matter basis is presented in Table 3. The pasture had a neutral detergent fiber value of 49.4% and a crude protein content of 16.3%, indicating moderately good pasture quality. This table continues from the one on the previous slide and includes the macro and micromineral content of the concentrates and pasture. It is evident from this data that the pasture had a manganese, copper, and zinc deficiency. A rising plate meter was used to assist with accurate pasture allocation. The measured pre-grazing and post-grazing rising plate meter heights were 30 and 11.6 respectively. The body weight and the body condition score of the cows on the control and the Aspergillus RSA treatment before and after the trial can be seen in Table 5. Body condition and body weight were unaffected by Aspergillus RSA supplementation. This slide presents data on milk production and composition, which are the most relevant factors for farmers. The cows produced an average of 20 kilograms of milk per cow per day, with milk, fat, and protein content at approximately 5% and 4% respectively. There was a trend for a 0.23 percentage unit increase in milk fat content in the Aspergillus oryzae treatment group. Additionally, no differences were observed between treatments for milk yield, milk protein content, milk lactose, milk uronitrogen, and somatic cell count. Various techniques exist to determine the dry matter intake of cows in a pasture-based system, but each comes with its own set of challenges. In our study, we used the titanium dioxide method to estimate the average individual pasture intake of cows. The control group had an intake of 7.42 kilograms per cow per day, while the Aspergillus oryzae treatment group had an intake of 8.78 kilograms per cow per day. This resulted in a total dry matter intake of 12.9 and 14.2 kilograms per cow per day, respectively. However, no significant differences in dry matter intake parameters were observed between the treatment groups. We will now move on to the rumen study data. The graph presents the rumen pH of the cows on the control and Aspergillus oryzae treatment over a 24-hour period. The arrows on the graph indicate the times when the cows were in the milking parlor consuming concentrate. A drop in rumen pH after concentrate consumption can be seen in both groups. The Aspergillus oryzae group had a lower rumen pH compared to the control group and remained below a pH of 6.2 for a longer duration. However, the pH of the Aspergillus oryzae group still remained within an acceptable range and did not compromise rumen function, as evidenced by the sound rumen parameters. Table 9 shows the total rumen volatile fatty acid and ammonia nitrogen concentrations. The rumen volatile fatty acid concentrations for cows in both the control and Aspergillus oryzae treatment groups were around 111 millimoles per liter. There was no difference in individual volatile fatty acid concentrations or the acetate to propionate ratio between the two groups. The rumen ammonia nitrogen concentrations were 11.4 milligrams per deciliter for the control group and 9.94 milligrams per deciliter for the Aspergillus oryzae group, indicating that the cow's dietary protein intake was sufficient. No significant differences in rumen ammonia nitrogen concentrations were observed between treatments. This graph shows the progression of dry matter degradability in rumen cannulated cows on the control and the Aspergillus oryzae treatment. There was no significant difference in the dry matter degradability between treatment groups. This graph is similar to the previous one, but it shows neutral detergent fiber degradability. No differences were observed in the NDF degradability between treatment groups. It is also evident that even though the Aspergillus oryzae group had a slightly lower pH, the fiber degradation was not compromised. In our study, the rumen environment of the cows was not under significant pressure. We suspect that if the rumen environment were more pressured, such as when higher levels of concentrate are fed, cows might respond better to Aspergillus oryzae supplementation. To conclude, in this study, the supplementation of Aspergillus oryzae fermentation product at 3 grams per cow per day to Jersey cows grazing ryegrass dominant pasture in spring did not affect the milk production but tended to increase milk fat content. The volatile fatty acid concentrations, rumen ammonia nitrogen levels, dry matter and NDF degradability, and dry matter intake were unaffected by Aspergillus oryzae supplementation. Although the rumen pH was lower for the Aspergillus oryzae supplemented cows, it did not compromise rumen function. Thank you for your time. If you have any questions, please feel free to scan the QR code with your phone's camera to send me an email. Enjoy the rest of the presentations by our team of esteemed researchers.
Good day, this is Leonie Jansen van Rensburg. I'm the state veterinarian for the George area, and I'm providing an update on the foot and mouth disease situation as it is currently in South Africa. So by means of introduction, just a bit on the virus itself. It is a highly contagious disease, foot-and-mouth disease, and it's caused by a virus. Highly contagious meaning it spreads very quickly. The virus causes blisters and sores in the mouth, on the gums, lips, and tongue. And what you basically see is that the animals don't want to eat, they have difficulty eating, and you get this salivation, so you see lots of saliva dripping down. These blisters and sores can also be between the toes of the animals, so they struggle to walk, they might look a bit lame. But what we've seen in dairy cows is that the sores can develop on the teats, and it causes a drop in milk production, and it leading to mastitis, increases in somatic cell counts, and yes, we've seen quite bad lesions in dairy cattle. So this virus is excreted by saliva, urine, feces, and milk, so basically any excretions, and thus it can be spread directly or indirectly. Directly being when animals are moved to susceptible animals, infected animals having contact with susceptible animals, or indirect contact, and this is usually where humans play a big role, by means of vehicles. If the tires have gone through excretions and now are going to somewhere else, or the people's shoes or clothes is contaminated by some excretions and they don't wash and disinfect, and then they have contact with other animals, they can be a means of spreading the virus. This virus mainly affects cattle, pigs, sheep, and goats, so your cloven-hooved species, but there are some serotype differences as to which species they prefer to infect. And foot-and-mouth disease is a listed disease with the World Organization for Animal Health, which has major trade implications for trade in animals and animal products between countries. The incubation period for this virus is 14 days. It's usually a bit shorter, but this is the time between when an animal is infected up to when it's showing clinical signs. And this is important because that means for up to 14 days, an animal can look healthy but already excrete the virus and spread the disease. So in South Africa, where I talked about the different types of FMD viruses, we only have the Southern African Territory serotypes, SAT1, 2, and 3. In other parts of the world, you also have other serotypes, A, O, C, and Asia 1. And then in South Africa, we have FMD as a controlled state disease, and that is in terms of our legislation, the Animal Diseases Act, and you can see here in the table what the control measures are for foot-and-mouth disease. So a bit of history. Prior to January 2019, South Africa had a FMD free zone without vaccination that was recognized by the World Organization for Animal Health. So FMD is a disease for which the World Organization for Animal Health gives an official status. So they actually come and audit countries and decide what they can be recognized as in terms of their FMD status. So we were free without vaccination in most of the country. We had this infected zone, which was limited to areas where we had carrier buffalo. So buffalo that harbor the virus but don't show clinical signs. And you can see here that's in red on the map, which is basically your game reserves. And then we had a protection zone where we vaccinate cattle to provide a bit of a buffer, and then the light blue was the previous free zone. So in summary, the outbreaks from 2019 to 2023. From 2019 to 2021, there were 3 FMD outbreaks in the previous FMD free zone in Limpopo that have all been resolved, although a disease management area remains in Limpopo for foot-and-mouth disease. Then in May 2021, an outbreak was reported in KwaZulu-Natal, and it was found to be a SAT2 virus, and it was closely related to the one that caused an outbreak within the protection zone in northern Limpopo in 2019. So basically, when you're looking at the sequencing of the virus, it hopefully gives you a bit of a picture of where the virus came from, although it's obviously not sure, but it gives you some kind of indication. Unfortunately, this also infected buffalo in the Shoshului and Mfolozi Park. Just keeping in mind that this changes the status quo for the country if you've got carrier buffalo, which will be a source of virus in future. And this outbreak also spread to the Free State province. And this outbreak is still ongoing and not resolved. In March 2022, an outbreak event was reported in the previous free zone of Limpopo in communal grazing land in the Vembe district, and it was found to be caused by a SAT3 virus, which they think was likely due to a spillover from an outbreak in the adjacent protection zone. And then there was limited spread to Gauteng in April 2022 and was then resolved. But at the same time, outbreak was reported in Northwest on a commercial stud farm, which subsequently spread to Gauteng, Free State, and Mpumalanga, and it was caused by a SAT3 virus, which was also responsible for an outbreak in Vembe. So we think it is the same virus or type of virus that was spread throughout all these provinces, and it was spreading so quickly that I think everyone will remember that they placed a national cattle standstill on the country from the 18th of August to the 8th of September 2022, so that you just break that infection cycle where it's spreading and you're chasing behind the virus the whole time. Because as I said, there is that incubation period where the animals clinically still look healthy, but they're already spreading the disease. So to have just the cattle standing still and not moving for a period, so that you can basically see which properties are infected and which aren't, was just to break that cycle of quick spread. And during that time also the disease management areas were established in KwaZulu-Natal and in the Free State province. Then in 2024 we had the Eastern Cape outbreaks. So on the 2nd of May 2024, an outbreak of foot-and-mouth disease was reported for the first time in the Eastern Cape province, in the Humansdorp area. And the same SAT3 virus genetically was found that had affected all those numerous other provinces. And then on the 30th of May, another outbreak was reported in East London and found the SAT2 virus that was found previously in KZN, although they also found a SAT3 virus subsequently in that area, so it seems there was a co-infection in that spot. So currently, just to provide an update on which areas can be seen as FMD free, the Northern and Western Cape have remained free from foot-and-mouth disease to date. Gauteng has eradicated their outbreaks and is regarded free from foot-and-mouth disease as of the 13th of March of this year. Limpopo has resolved all their outbreaks in the previous free zone, but they still have this disease management area, which you can see here indicated on the map. And Mpumalanga has also resolved all their outbreaks in the previous free zone as of last year already, and Northwest can be regarded as foot-and-mouth disease free from the 5th of March of this year. So there still are unresolved foot-and-mouth disease outbreaks. Firstly, in the Free State province, what happened there, because there were commercial breeding herds and stud farms, they chose not to depopulate and slaughter all the animals, which means that they have to wait 12 months after vaccination before they can be tested to see if they are now free of the disease and quarantine can be lifted. However, there has been no further evidence of circulating virus, So the last reported outbreak was the 7th of February of this year. And basically we're now just waiting the 12-month period so that we can test all affected farms and prove that they are free. And then that disease management area in the Free State was repealed already on the 8th of September in 2022. So there's no more disease management areas in the Free State. KZN, unfortunately, there are numerous unresolved outbreaks in communal dip tanks and small-scale farmers. 5 of the game reserves have been affected, and like I said, this has major implications on having a source of the virus remaining. And also, if you now want to zone again for official recognition with the World Organization for Animal Health, this will have implications because you can't zone an area with carrier buffalo as free, which means that those areas will need to be part of a infected area, basically. The disease management area in KZN remains. You can see it's here in light blue. And then the last outbreak reported was not too long ago, the 4th of July of this year. Then in Eastern Cape, the Humansdorp area, there are 32 farms positive confirmed. And then these positive farms have been vaccinated. Because I mentioned that these dairy herds showed quite bad clinical signs, so much so that you got such mastitis that some cows were just not functional anymore, that farms in the neighboring farms basically applied to preventatively vaccinate their cattle on 37 farms in the area to try and prevent those bad clinical signs. A disease management area was declared in this area. You'll see the top map shows the disease management area, and then the last outbreak was reported on the 9th of July of this year. The East London area, where I said they found the SAT2 and SAT3 virus, there were only 2 farms affected, and it does not seem to have spread at all from there. So all of these outbreaks from 2019 up to the current ones have mainly affected cattle, and we are not sure of the role of other cloven-hooved animals in the epidemiology of these SAT type outbreaks, and it's still under investigation. So control measures. What do we do for foot-and-mouth disease outbreaks? Firstly, the most important thing is movement control to stop the spread. So affected farms and feedlots are placed under quarantine. These disease management areas where we have declared control measures, there no cloven-hooved animals, products or genetic material may be moved from, to, or within the disease management areas except under the authority of a state veterinary permit and in compliance with the conditions of such a permit. And in the whole country, you'll see the disease management areas are government gazetted. The last one for the Eastern Cape was this one that you see at the bottom here on the 26th of July of this year, and where it was declared what happens in the disease management areas. And it also states that in the whole country, if you're moving live cattle, sheep or goats, you need an owner declaration with regard to the origin of the animals, where do they come from, and are they healthy or not, the farm of origin. And then you also need an undertaking of the recipient that they are willing to isolate animals at the destination for at least 28 days. So that's 2 incubation periods to make sure that once those animals have contact with the resident animals, they're not spreading the disease. So on infected properties, the cattle have been vaccinated to reduce the viral load. That is to just make less virus available to try and lower the risk of spread from there. The vaccine is procured from Botswana Vaccine Institute and has all 3 SAT types included. Only government officials are allowed to vaccinate animals in South Africa. So on infected farms, there have been controlled slaughter to depopulate most of the farms, which decided to go that route. And at this controlled slaughter can only happen at designated abattoirs. They have to apply and be approved to slaughter from foot-and-mouth disease positive farms. And part of that is that the risk materials will need to be processed or disposed of at the abattoir, and only known safe products can then be released into the local market. So to resolve these outbreaks, either the farm has to be depopulated, and then 28 days after disinfection, the quarantine can be lifted. If the farm is not depopulated, like I said previously, then the animals need to be tested 12 months after the outbreak or the vaccination to prove freedom from the disease in order to lift quarantine. Just a note on vaccination, because not all vaccines are created equal, and there might be some misconceptions on the vaccine and how effective it can be. So only farms within 10 kilometers from a positive farm can apply to the National Veterinary Services for vaccination, and no foot-and-mouth disease-free herd will be forced to vaccinate. So I think people don't want to be forced to vaccinate if their animals are free, because there are implications, but they won't be. If you want vaccination on your farm, you have to apply and sign the indemnity, because if a farm is vaccinated, they will be regarded as foot-and-mouth disease positive. So effectively they will be placed under quarantine. They'll need a state vet permit for any movements off the farm until the restrictions are lifted, and this will be effectively for 12 months until you can test to prove freedom. And the first 6 months you can only slaughter at designated abattoirs, and there are not many of those currently. And the milk will have to be double pasteurized or undergo a ultra high temperature treatment, and the products can't be exported. And keeping in mind why I say not all vaccines are created equal, vaccinated farms can still become infected. And because this is an inactivated vaccine, immunity only lasts approximately 4 to 6 months. So you see, the thing is that we can't consider or see a vaccinated farm as foot-and-mouth disease free, because you still would need to check whether it has become infected, but the vaccination decreases the clinical signs, so it makes it more difficult to detect the disease, and it also will most probably test positive on serology, so it's difficult to prove that the farm, once it's vaccinated, is free of the disease. So you see, even though you vaccinate, you will need to have biosecurity to protect your animals still. So in all of the scenarios, biosecurity remains crucial, and vaccination is not an easy solution to foot-and-mouth disease, unfortunately. Regarding biosecurity, biosecurity is more a way of thinking about your farm and how things move on the farm, that it is just a physical thing. So once you think about biosecurity, you should look at your control boundary. So where do you want to keep things biosecure? So your animals, what will be the boundary for that? Will it be your fences? Will it be a road? What is it that you would demarcate? This is biosecure area, and the rest is not biosecure. So that is where things can move freely and it won't pose a risk to my animals. And you have to think about that in terms of, it sometimes helps to just have a map and look at where your animals move, where vehicles move, where personnel or other people move, and you map that out so that you can see where is it that these cross, where there's potential contact and contamination. And then you look at those access points where there is potential crossing and demarcate that clearly and put in some risk mitigation measure at that point. So, for example, no access of vehicles or equipment or personnel to that biosecure area at that gate or whatever you see as your critical control point without proper decontamination and disinfection obviously part of biosecurity, the most important part is that you should only bring in animals from guaranteed healthy herd, and remember your obligation in terms of legislation to have it isolated for 28 days to check that there's no clinical signs before introducing it to other animals. Your feed, remember your feed must come from safe sources, and as I mentioned before, that 14-day incubation period where the animals do not show clinical signs, that is when it can spread without anyone being the wiser. So movements at this stage where we know there is virus circulating in the country, we should keep movements as limited as possible until we know there is no more circulating virus in the country. A note on the virus inactivation. So high temperatures can inactivate the virus, but the virus is preserved by refrigerating and freezing. And there are some guidelines for how to inactivate the virus by heating. So the virus is also sensitive to pH changes, so a pH of less than 6 or more than 9 will also inactivate the virus. But then you also have to think about disinfection. Not all disinfectants are effective against all types of disease agents. So some are more effective against bacteria, some against protozoa, and others against viruses. So you should think about your disinfectant. Is this one effective against foot-and-mouth disease virus? And then also there's a specific concentration at which it is effective. So you have to make sure that the concentration of your disinfectant is effective against foot-and-mouth disease, and that whatever is being disinfected has the prescribed contact time with the disinfectant for it to be disinfected. And a very important thing is most disinfectants don't penetrate inside organic material for proper disinfection. So what this physically means is if you've got manure or something on your shoes, first remove that before using the disinfectant. The same with vehicle tires, all of that. If you've got mud or manure or all of that, first that has to be removed, then you disinfect to make sure that it is effective against foot-and-mouth disease virus. So there's just a table with some of the active ingredients which are effective against foot-and-mouth disease and the concentrations and contact time that you will need for it to be effective. Just a note on the responsibilities of animals and animal owners and land owners. So Section 11 of the Animal Diseases Act gives that responsibility that animal owners as well as the owners of land where animals are kept have to take all reasonable steps to prevent infection and to prevent the spread of infection if it does occur on the farm, and to then eradicate the disease, and of course also to report it to your local state veterinarian. If there is an outbreak, the animal owner also is required to let their neighbors know, as well as any prospective buyers, that they have had an outbreak in the past 30 days. So this is all part of the Animal Diseases Act, and you can be kept liable if you contravene what is the responsibilities prescribed by the Act. In conclusion, I just want to have a discussion on the risk to the Western Cape. So at this stage we are still foot-and-mouth disease free, and we would like to keep it that way. And the greatest risk will obviously be infected livestock, because they're the ones that are producing virus and can spread it most easily. This is a highly contagious disease, so it does spread very easily, even though the mortality rates are very low. So you don't get many animals dying from the disease. It is still a devastating disease in terms of loss of production, loss of trade, and all of that. So at the moment, it would be advisable to really move as little livestock into the Western Cape as possible. Remembering also that indirect contact, so the products of animals, their feed, bedding, people who have been in contact with infected animals, and their clothes and everything, equipment, anything that has been in contact with infected animals can spread the disease, and one should always be thinking of how this disease can spread and take that responsibility to please not bring it into our province. And yeah, because it will be catastrophic if we do get the disease, and not only for the animals but for the economy of the province, because it endangers basically food security, jobs, trade, and it is really devastating to farmers who have to witness and experience the loss which is caused by such diseases. So we really need all sectors to work together to prevent the entry of this disease, which has devastating consequences. So I thank you for your attention to this, and then there's my contact details if you do have any questions.